Okay, so good afternoon, everyone. You don't need your video. I repeat again. So you don't have to turn on your video, and please mute yourself as soon as you are entering into the classroom. There is a chat window. If you click the chat window, it will open up on the right side of your screen, so that I can see if any one of you have any questions. If you can't hear me, you can straight away type in. I can see all of your chats on my right side. I have two screens, one with the PowerPoint slide, and another one is I have the full control of the Zoom, including chat and all the participants entering into the classroom. So again, welcome everyone after the unexpected midterm break. So it was kind of a shock. All on a sudden, we received that email from the Vice Chancellor that all the classes will be paused until March 30. So what happened is, you all know the midterm break was, this will be treated as the midterm break. We won't be having any more midterm break in April. Yes, it was a boring break. Okay. So all of you are home quarantine, including myself. I'm not going outside or doing anything outside. Every part of university business is now closed. We can't go. Can you please slow down it, please? So it's hard to follow you. Okay. Okay. I'll talk a bit slow. All right. Now we started lecture 5. Developing project plan as soon as we finish lecture 4, and this is all about developing the network diagram, and we looked into some fundamentals of how we can develop a project network diagram. We discussed about the what is project network, what is critical path, then how we can integrate the work breakdown structure into how we can take the work breakdown structure into the project network diagram. So if we have the work breakdown structure that can be integrated into the project network diagram, now how we can construct it. We discussed in the previous, so this is just a recap to where we stopped in our last lecture. Now, before I begin, there is as I posted through iLearn, will there be any change of assessment task now? Yes, so there will be change of assessment task. So you don't have the participation marks anymore. The group project is still there. I will post through iLearn about how the new assessment task will work. Is the lecture recorded? Do you want me to record it? Yes, it is recorded. Yes. The lecture is recorded. Yes. Okay. All right. So now, as you can see, so as I said, all the assessment tasks will be changed. There will be a new format. There is like no participation marks. Exam will be 50%. The group project is still there. I discussed about how we can best manage the group project. Group project will still run, so you have to form a group with a team of 4 people. That is still there. I will post through iLearn what are the new assessment tasks, what are the new assessment components that that in this online format. Now, those who are writing on the screen, if you could please stop so that I can continue on my lecture. Okay, so we were discussing about what is activity, what is merge activity, what is parallel activity, then the critical path. the longest path in the project network. I'm still receiving some more questions. So will the exam be online? Is the exam going to be online? There will be final exam of 50%. We haven't decided yet how the exam will take place. So we will receive final communication from the Vice Chancellor how we plan to conduct the exams. It can be online, or if the situation changes, it can be maybe it can be depending on situation by mid of June or by the beginning of June. We will decide how the exam will take place. Yes, there will be a final exam. Yeah. It may be online. I don't know yet. It haven't decided. You will receive a final communication what the exam structure will look like. Okay. So from time to time, I will look into the questions that you may have, and I'll try to answer. Okay. So now. We already discussed this this slide in our previous lecture. What is critical path? The longest path along the activity that allows the completion of all project-related activities. All right. Then the next is activity on node, activity on arrow. Out of these two approach, we followed the activity on node. Burst activity is if any activity is bursting into multiple activities. Then we discussed about activity on node fundamentals. Next is so in here we decided about how we can by looking into the activity, we can relate that into the proceeding into the preceding activity. Like A is B is preceded by what? All right, A. C is preceded by B. All right. Okay. So from the activity diagram, then we started discussing about the forward pass, or the early start, early finish, and how soon we can finish the project. And then we also discussed the backward pass. Then we talked about the duration, how many days each activity can take, activity name, and the preceding activity. So A is preceded by none, then B is preceded by A, C is preceded by A, stuff like that. Then we start forming the network diagram. Once we are here, then we discussed about the forward pass process. So in simple word, if you look at the legend here, all right, this is ES for early start, early finish, project ID or activity ID. This is for the forward pass approach. So early start is the earliest time that we can start an activity. Then we saw in a step-by-step process how we can form this table using early start, early finish with the ID, and how we can determine the duration. So duration is the difference with the early start and early finish time. And then once we are here into the next slide, we can see that we can identify the total project duration, how much time it will take to complete the whole project. All right, so up to this slide, I think I covered a few more in my last lecture. Okay, so just to repeat, I repeat again, just to recap where we ended in my previous lecture. The longest path from here, starting from A, C, E, H. So this is the critical path. Within the network diagram, we have three three parts, 1, 2, and 3 parts in the project network diagram, and out of these 3, 2 is the most critical. This is what? This is the longest part in the project network diagram, and also this is the shortest duration that we can finish the project on time, which is 100 days. And all activities within the critical path, these are all critical activities. That means we cannot negotiate, we cannot compromise with any of these activities within the critical path. Okay, fundamental rules about the forward pass computation. So it starts from early start ES plus duration equal to early finish. That's how we calculate EF if you have the ES. And then in the backward pass process, now that we know we exactly have 100 days as the project duration. So we know the duration of each activity, which is here. All right. If you subtract the late finish, so this is late finish, late start, and the duration. If you subtract the duration, we have the late finish. As we go, so we can follow the backward pass process from here. 85 will be carried out here, here, and here. All right. So if we have 2 late start in a chain, let's say we have 35 and 70, which one will be here? That is the lowest of both late start. Okay, this is 70, and we now have another one, 35. So the latest late finish of C should be 35. That means we cannot delay anything later than 35 days for C for E to start. All right. Now we covered up to this slide in my previous lecture. So using the backward pass, so we can have more clear indication of the total slack or how much flexibility we have within the network diagram. So if I have the now these are the next slide shows the backward pass computation process. So it is in simple words. So you subtract the duration from LF and then you get LS. All right. Now the total slack. The slack is our flexibility. We need to understand. We need to know the total slack within the project network diagram. This is our flexibility to complete any project on time. How much flexibility we have. So if you look at the project network diagram in the previous slide, you can see that there will be some differences between the early start and late start. And the difference of early start and late start, this will be known as the slack, or how much buffer we have within each activity. That is the slack. There are 2 types of slack in any project network diagram. We have the total slack, or we also call it float. So float is something like when the forward pass and the backward pass as we now have the numbers ready in the project network diagram. Then if we see the differences between the early start and late start, that is the difference of, that is the total slack. So it is known as total slack because this is the total amount of slack we have in each project chain, each network chain, right? So we have, say for example, if we have 15 days of slack in one of the chain, that means we have 15 days for the entire duration of that project network diagram. So if we use 3 days out of 15 days, that means the remaining slack we have is 12 days. That is the total slack. In simple words, so the total slack is the total flexibility that the accumulated flexibility we have in any project chain, in any network chain. So it tells us the amount of activity can be delayed or not delayed by not delaying the project, and how long an activity can exceed its early start or its early finish date without affecting the project end date. So remember remember, we are not affecting, we are not compromising with the total project duration. The total project duration stays the same, 100 days, but we still have some flexibility in the other chain that we that you can play with. All right. Now, in the forward pass and backward pass, completed Slack with the Slacker. So this is the completed project network diagram that gives us a clear indication of the number of Slack. All right. If you look at the okay. So if you look at the critical path, you can see that the total slack will be 0 days within the critical path. Okay, so that's because we don't see any differences between the early start and late start. There is no difference at all. And the amount of time, that means we don't have any flexibility, nothing on the critical path. So critical path stays as it is. We don't have any flexibility. Now on the in chain 1, if you look at the first activity within chain 1, activity B, we can see there is a slack of 15 days. So that 15 days, 15, 15, 15. This is the total slack. And that if we don't use out of those 15 days, that will be carried over to the next activity. So this is the total slack within the entire project network diagram, within the entire chain 1. We have about 35 days for the chain 3. And this is chain 2, which is the critical path, CR. Okay. So using the forward pass and the backward pass, we have a completed project network diagram with the slack times, and that shows the total slack. Okay, then the next is what is free slack? So this is a bit of different than the total slack. So within the free slack is related to each activity. So it is the amount of time an activity can be delayed after the start of a longer parallel activity or activities. So if you look at the description of the free slack, so this is how long an activity can exceed its early finish date without affecting the early start date of the successor. So free activity, free slack, this is a bit of different than the total slack. So within a chain, if we finish an activity, free slack is related to each activity within the chain, and the total slack is for the total chain. All right. So it is I should have an example here of the free slack. Let me see, but in simple words, so this is related to each activity within the chain, and the total slack is for the total chain, right? The only activities that occur at the end of chain activities where you have a merge activity can have a free slack. So this is a very critical statement about the free slack. Only activities that occur at the end of a chain activity, which means if you look at in the previous slide, okay. So at the end of the chain activity, only we have 3 chains: chain 1, 2, and 3. Out of these 3, do we have any free slack here? Can you check? Anyone? I repeat again, free slack is only at the end of a chain activity, right? So if we look at here, if we have 15 days of total slack, 15 and 15, then we have no slack on the critical chain and 35 days of slack on chain 3, right? Now that we have, if we are at this stage, okay, so if we don't use 15 days in first two activity, how much free slack we have on activity G? 15, right? Okay, so in simple word, if we don't use any of this slack from the previous activity in the chain, if we don't use this, the entire slack will be carried over to the very last activity. And the amount of total balance of slack is known as the free slack. Is it clear now? All right. So in activity F, we have a free slack of 35 days. Okay. But say, for example, if we use already 8 and 2 days of slack in here, amount of free slack we have at the end of chain activity will be 5. So this will be changed into 5. 5 days will be the free slack at the end of chain activity. So free slack is the very in the very last activity of any chain, the amount of balance we have out of the total slack is known as the free slack. All right. Then the critical path, we all know what is, we've been discussing a lot about the critical path. So this is the longest path that have the least slack in common. Look at the keyword here, the least slack. That means the lowest amount of slack, or in most of the cases, the slack will be 0 on the critical path. This is the longest path and shortest expected time that a project can be completed. Then it is important because it helps us in identifying the total completion time. If we are really constrained by the resources, we need to know what is the critical path so that we can allocate all the resources on the critical path. So that helps us in identifying or paying the extra attention when doing risk assessment or allocating resources on the critical path. This is where all the engineering managers they look when they are asking to borrow people or equipment. So if you are working as a project manager of a big project, and you know that the task or activity is on the critical path, so you don't have any flexibility. You can't allow anyone to lend human resource or any sort of equipment from the critical path. All right. Then the next topic is network sensitivity. Any questions till this point? I'm looking at the chat window and also the number of participants we have. Okay, all good. All good. Okay, network sensitivity is it's like how sensitive the project network is, or in other words, the likelihood of changing the original critical path if we change the project scope, or if any of the activities is changed, whether there is any chance of changing the critical path. So that is known as the network sensitivity. It's a very critical issue, especially we have a highly sensitive network when we can see there are multiple chains which is very close to the critical path. That means the total slack is, the number of total slack is less than, say for example, less than 5 days. And on the critical path, and if it is less than 5 days or very short number of days, if we delay any of those activities, that chain will become the critical activity. So network sensitivity, it is a network schedule that has only the critical path and non-critical activities enjoy the significant lag. In other words, we if we take more example, if you take an example from the previous project network diagram, this project network diagram is not sensitive, just because we have 15 days and 35 days of slack in other chains, right? We have the critical chain, and chain 1 15 days, and chain 3 35 days. So say for example, we have a project network diagram which consists of 10 different chains, okay, and a number of chains has a total slack of 5 days, 3 days, maybe one with a slack of 2 days. So this is a highly sensitive network. Any of the activity within that shorter chain, within the shorter slack, if that changes, that will become the critical path. So the original critical path will change if we have a sensitive network. If you have a shorter total slack in a very complex project network diagram. That is network sensitivity. Some practical consideration: network logic error, network activity numbering is the computer to develop the network or the Gantt chart. Then start with the calendar date so that we know exactly the public holidays and weekends, or if any other if there is a long weekend or any other holidays within the in the planning process. That's why we need to use the calendar dates. Multiple start and multiple projects. We'll go one by one. So what is a network logic error? I think we briefly discussed about this in the previous lecture. So there will be no if statement and no looping. That means we cannot take if from A to B, from B to C, then C again move back to A. No looping process, no if statement. These are the network logic error. Then use of computer system, numbering activity, use of computer to develop the project network diagram. Now at this stage, we have a software that you can download, Microsoft Project Professional. We have the 2016 and 2019 version. I will give you the link to download the software and you can install. We'll learn the software in the upcoming one of the upcoming weeks. I will show you all the video instructions and how to download the software and install, so that you can continue your group project using the software. This is an example of how we can use the software to develop the Gantt chart. Now this is again a screenshot taken from the Gantt chart. As you can see that if we have the ID number, if we have the duration, task name, and this actually the start and finish time, it follows the calendar dates. So that takes into account by default if there is, yes, it is Microsoft Project Professional. (2016) or 2019. Okay, I repeat again, you'll have the link to download the software. You don't have to buy it. It's expensive. The software is expensive. We have both the 2016 and 19 version. Depends on what Microsoft Office you use. If you use 2016, you have to install 2016. If you use 2019, then you have to install the 2019 version. Now again, there are 32-bit and 64-bit. If you are using the Macquarie University Microsoft Office in your laptop, it is most likely 64-bit version, and you can check your system whether the Microsoft Office you install, either it is 32 or 64, then you download the relevant file and install. All right, that is coming. I will instruct, develop an instruction, where to download, how to download, which file to install. Okay. Then in our next topic is layering, extended network technique. Now that we have the basic structure of the project network diagram, now let's look into some more fundamental details of the project network diagram as we go into more complex area. What is layering? So an activity broken into segments so that the following activity can begin sooner and not delay the work. It's a type of how can I explain this? So say for example, if you have multiple tasks A, B, and C, you can still before even finishing one activity in one of the chain, if you have the resource to start another activity from another chain, you can start it. All right, so layering is not waiting until, so dividing into multiple segments so that activity can begin sooner. I have some examples here in the next slide. So the use of layering. So say for example, in a civil construction projects, if you look at the simple diagram here, in a civil construction projects, if we are to construct underground pipeline, say for example 10-kilometer long underground pipeline to be constructed by the civil engineers, and the basic process is, first of all, we have to dig, we have to make the trench, then lay pipe, and then refill with the concrete and dirt, whatever it is. So that means if we have a job like this, if we isn't it the best practice that if once we finish 1/3 of the trench, we can start laying pipe in that portion by the time we are digging the rest of the 10-kilometer trench. Okay, so that means as soon as we have 1/3 trench is done, we can start laying pipe. We don't have to wait until all the 10-kilometer trench is done. In the conventional approach, it shows that once you finish the trench, then you can start laying pipe, then you can refill with concrete and dirt. But in real case, we can start laying pipe as soon as we have 1/3 of the trench done. Then it follows. We have the remaining 1/3 and the remaining 1/3 from here. We lay pipe. Once 1/3 of the lay pipe is done, we start refilling. So we are not wasting any time. So starting simultaneous task before even one task is finished. If we are allowed to start that, if we are allowed to start the following task immediately, that is known as the layering process. So from the definition itself, you can see if we can start and if we can begin an activity sooner by not delaying the work. If you have the flexibility, if you can start it sooner, let's do it. Let's do it. So that's a layering process, doing simultaneous tasks at the same time. And it is true for every single engineering project. There will be lots of different activities that you can still. Can you explain the layering again? Let me see if I have another diagram here. Leg. Okay, this is a layering process. We also call it concurrent engineering. right? So that means start planning a process before, if you have the capacity to start an activity before even finishing the previous activity, let's start it. So this is the layering process. So in the conventional approach, you can see this is the conventional approach on the top of the slide. All right, this is the conventional approach. So what it shows, from the product planning to systems engineering, then design, then procurement, then manufacturing, then quality assurance, then release the product. This is the conventional approach. This is the traditional approach that has been on practice for a long time. Within the concurrent engineering, if we follow the layering approach, what it means is, within the product planning process, as soon as we have the product planning process, we start working on the systems engineering. All right, when the systems engineering work is undergoing, if we have the capacity, let's say for example, we finish 1/3, okay, then this is 2/3, this is all of it. If we finish 1/3, as soon as we finish 1/3, we start designing the engineering design and development process based on what system engineering task we completed so far. We don't have to wait until the entire task is completed. Then the procurement team will be waiting for collecting orders, get the database updated, what we need, what we don't need in the engineering design process, what we need to buy, look at the inventory database, how much of the equipment we need. The procurement team starts working straight away. As soon as we have the engineering design and development team, they have at least 1/3 or 2/3 or 50% or 40% of the task is done. The procurement team now have already some idea about what to buy, what not to buy. So they start working on the purchasing process. And then the next step is manufacturing and production. Now, the manufacturing and production, they are very closely linked with the procurement team. They know exactly when the lead time is, when all the bits and pieces are coming, and they can start the fabrication manufacturing process. So that is, they don't need to wait until all the procurement is finished and then they can start manufacturing process. So this is not an usual practice. They are wasting time. So they can start planning as early as the procurement team took control of what is needed, and the manufacturing team will start accordingly for planning and preparation. Quality assurance, step-by-step process. As soon as we have this done, that can go to the quality assurance process. So this is layering. So you can see that this is the total lead time from start from start till end. Okay. So as you can see from here, we now have significantly less time to bring the product into the market, right? This is like we are saving a lot of time to bring the product into the market simply by following the layering approach or concurrent engineering. We don't have to wait for each of these steps to be completely finished. Okay, so that is the layering approach. Now, do you want me to repeat again? Is it clear? Okay. So this was a very simple example of the layering approach, right? As soon as we have 1/3 of the trench, we can start laying pipe. As soon as we have as soon as this is done, we can start refilling that 1/3 portion. So we reduce the total duration of the project. Okay, so that is known as the layering. And legs. So legs is the minimum amount of time of a dependent activity must be delayed to begin or end. So legs are related to two activities, two simultaneous activities, one after another. how much lag we have. So the minimum amount of time a dependent activity must be delayed to begin or end. I will give some more examples in the upcoming slide. If you read the if you read the statements here, so lengthy activities are broken down to reduce the delay of start and of the successor activity. So this is part of what? This is part of the layering process. So in the layering process, we need to divide the lengthy activities into multiple smaller tasks. As soon as we finish that small portion of the task, we can possibly start another activity from the following within the chain in the another following activity. But if we start the layering process, an important parameter that we can look into is the lag or the lagging process. So how the lagging process works. Lags can be used to constrain the finish to start, start to start, finish to finish, start to finish, or a combination of relationship. So we have multiple types of lags. One is finish to start. Finish to start is how much time delay we have from finishing. If you look into here, so activity A, if we finish it, this is activity B, right? So this is from finish to start. So once activity A is finished, then we can start activity B. This is finished, this is start. How much time we have? Say for example, we have 3 days of lag. So this is the total lag, this is the time delay we have in 2 of the activities. Okay, so it can be start to start. Start to start is something like we have an activity A, activity B. All right, so this is the start of activity A and this is the start of activity B. How much time we have from starting A to starting B. We can have also finish to finish in a similar word, or start to finish. So start to finish relationship. Say for example, we have use of lags. We have multiple activities. In example A, this is a start to start relationship. All right. Can the layering be different for the same project? What is the basic purpose of lag? Can the layering be different for the same project? Not sure what you are really asking. Layering can be related to each of the chain within the project network diagram. It depends on the chain. It depends on the chain. So that is the purpose of layering is to shorten the total duration of the chain. And what is the basic purpose of lag? So lags helps us in optimizing the network diagram. That means if we know exactly how much lag we have from start to start, we can start planning the following procedure. So say for example, we have a start to start relationship in this slide, which is A, activity M. This is the start time of activity M, and this is the start of activity N. All right. So another task B, we have, say for example, from activity P to activity Q, we have a lag of 5. That means we have from the start of activity P, within 5 days, we'll be starting activity Q. So this is the start to start lag. right? So from the start of P, we have 5 days to start Q, so that we know exactly when Q will be starting, and we can start the planning and preparation for activity Q. This is start to start. We can have use of lags. So say for example, use of lags to reduce the schedule detail and the project duration, as I said. So layering and lags, so these are all related to reducing the total project duration. In the conventional approach, what if we look into the basic steps, if we have a big project like this, 10-kilometer build trench, lay pipe, and then fill with concrete and dirt, it takes, so if you look into the conventional approach, what we usually do is we build the trench, then we lay pipe, then we fill it with dirt. But if we follow the lagging approach, that means we don't have to wait until the entire trench is done. So 1 mile is done. This is a start lag of 3. Within 3 days, we'll start laying the pipe. Then in another 3 days, we'll start refilling. So use of lags to reduce the total duration of the project. So if we know the lag 3 here, we start planning on the piping process. Is it clear? Okay, so engineers or people who are working on the next step, they know exactly how much lag they have once this is started. Within 3 days, they will be starting laying pipes. So all the pipes, make it ready within 3 days. So lag means totally delay. Not totally delay. It's not delay. It's the minimum time. Yes, that's right. It's the minimum time to start the next step. That's a clever answer. Yes. So that means within 3 days we'll be starting the following one. It's not delayed. It's not delayed. The trend. So in most of the civil construction projects, right? In most of the civil construction or any other engineering projects, for any dependent activity like this, for laying pipe, this is a totally dependent activity on what? On the trench. If we don't have the trench, we cannot lay pipe, right? Same goes for the refill. We cannot refill until the piping is done. All right. So when the piping team they can start planning and preparation. They can't just sit idle, and they can't just wait until they have the approval for trench, or 1/3 of the trench is done, then they can start. No, they should be updated as soon as when the trenching process will start. When the engineers will be start on the trench, then the piping team, so that how much time they have. They have only 3 days to start the piping process. That means within 3 days, this is not waste. This is actually when the trench is being built. Is it somehow related to the free slack? Lagging? No. Lagging is not related to the free slack. No. Lagging is a bit advanced level of planning and preparation. That means the notifying the following team of the people who are related to the following activity that we are starting now. In 3 days, you can start your work. You can start laying pipe, or whatever the task is, you can do it. This is about lagging process. So lagging is within all the existing resource, we are reducing the total project duration. Okay. So some other use of the lags. So use of lags, finish to finish relationship. Okay. So finish to finish, as you can see from the name itself, from this finish to that finish, we have 4. Now, what does that mean? That means we we have a lag of 4 to finish the testing process once prototype is finished. You want me to repeat? We must finish testing within 4 days once we finish the prototype process. Okay, so this is finish to finish. So we are restricting time for manufacturing and testing. Now we have only 4 days. As soon as we have the prototyping step done, within 4 days we must finish the testing process. This is a finish to finish testing. That means we are limiting the extreme time the following activity must be completed. This is a finish to finish. Start to finish. Once activity A, say for example, this is activity A, which is testing. Once testing start, the system documentation must be finished within 3 days. So this is, now we are relating start of an activity to finish of another activity. Start to finish process. So starting the testing process A, as soon as this one started, in the next 3 days, we must finish the system documentation process. So start to finish relationship. The next one is a combination relationship. That means what? That means we have start to start or finish to finish. We can have multiple approach. We can have multiple approach, a combination approach. So finish to finish. So once this is finished 4 days. This is started and this is started 2 days. So these once coding is started, within 2 days debugging should start. Is it clear? Okay. All right. Which one you want me to repeat? A, B, or C? Okay. Combination activity C is now if so A and B is crystal clear. All right. So A and B, finish to finish, start to finish. That means we are restricting the following activity when, as soon as this one finished, how this is related to the following one, when the following one. So we are restricting the time. In a combination activity, we can have finish to finish and start to finish. We can have multiple legs. So this is a bit more advanced lagging process than a single lagging approach. So we can have multiple lagging approach in the combination process. If this is say for example M N, two separate activity, one after the other. From start to start, say for example here from start to start, we have a lag of 2. That means N or debugging should start within 2 days when coding started. Start to start within 2 days. Then finish to finish. That means once coding finish, within 4 days, we must finish the debugging process. We cannot delay the debugging process until the maximum time we have to finish the debugging process. Once we finish the coding process is 4 days. So it's a both-way restriction. We are restricting the start and we are restricting the finishing time, both. So this is a combination lagging process. One is a start to start, once coding start, debugging must start within 2 days. Okay, once coding finished, within 4 days, debugging must be completed. That means we are clearly restricting the starting of the debugging and the finishing of debugging process. And that is very closely related to the coding process. So from coding start to coding finish, debugging start, debugging finish, clearly dictated by the previous step through the lagging process. Is it clear now? Yep. Yes. I just like the interface. I mean, you are answering, and you are you can see that it's very interactive. It's still, you are not in a face-to-face setting, but it's still you can interact with each other, and we can all hear the answer you have. So does it also mean that for start to start, you have to finish coding in 2 days and start debugging? No, for start to start, you don't have to finish coding. No. Does it also mean that for start to start, you have to finish coding in 2 days and start debugging? That doesn't mean you have to finish coding process. So debug 2 days after the start of coding. That's the appropriate answer. Yes. So in simple word, the debugging team, they know exactly when the coding started. All right, let's get ready. In 2 days time, we have to start the debugging process. And we'll start debugging. Whatever coding is done, we'll start debugging on that process. That doesn't mean they have to finish the entire coding process. No. Okay. All right, in the next slide is so network using legs. You can see multiple activities. It's a very simple network that shows the early start, the duration, and the early finish, and the late start, late finish, and the slack, the total slack in all the chains. So if you look at here, using legs, so that means what? So from activity A to activity B, so the start of activity B, there is a lag of 3. Order hardware, so design, okay, system design and hardware ordering process. This is the start, and this is the start. There's a lag of 3. So the hardware team, they know exactly in 3 days time the ordering process must start. Then if you look at here, if you look at into the into installing hardware somewhere here, so this is from finish to start. Okay, there is a lag of 4. So this one can be related to this is what? This is the early finish time, and this is the early start time. That means we have a lag of 4. So from finish to start, we now have a lag of 4. From here, this is from finish to start. We don't have any lags on this install hardware and then install software. There is no lag. From here, we have a lag of 2. So the system testing team, they know that this is from start to start. All right, as soon as this is started, okay, so the testing team, they can start preparation and they can start. So we can see from here, right? It can be in a project chain. It can be related to the early start time of all the relevant activities. Okay, now depending on the type of lagging, whether it is from finish to finish or from start to finish, we know that this can be related to the early start time. Okay, so from this one, from finish to finish, there is a lag of 0. That means there is no lag. We must start straight away as soon as this one. So from finish to start. Okay. Then we can see some other lags here. So there is a lag 2 on this chain. That means once from finish to finish. We can see this is the late finish 16 and late early finish 16 and early finish 18. We have a lag of 2. So if we know the exactly how much lag we have from finish to finish of these, testing system and install software. So within 2 days, we must finish testing system once we finish the install software activity here. All right. And again, if you look at another lag of 2, this is from finish to finish. Okay. All right. So we have a lag of 2. That means from early finish to early finish, there is a time delay. There is a difference of 2 days. So we can relate that to a lag of 2. So that must be finished within 2 days as soon as the testing system finished. Any questions, please? So lagging is, it can be related to the early start, early finish time. All right. If you look at the legend here, so if we do lagging process for better planning and preparation. All right. The system documentation team, they know that within 2 days, now this is the lagging process. They know within 2 days they must finish system documentation as soon as the testing of the software is done. We don't consider the duration while lagging given in this. It depends on consideration of duration. It is somewhat embedded into the process. Say for example, if depending on the type of lagging process, we have start to start, start to finish, then finish to start. Okay, so in a start to start lagging process, if we take the first one here, start to start, okay. So I'm getting some questions here. So talking about the activity D to E, consider this is a combination lagging process. Yes. Activity D to E is a combination lagging process. Then talking about ID, if we calculate ES and time of duration, so our early finish would be 14 then. So if you look into E, all right, so if we look into E, then our early finish will be 14. Okay, so that's a very good question. So if you look at D and E, we have For D, we have the duration of 6 days. So from early start, duration of 6 days, we have the early finish 16 days, which makes sense, right? But the following one, which is the testing or activity E, we have the early start of 12 days, right? And the duration of 2, that should make the early finish to 14 days, but this one is 18 days. So that means, although we have so from D to E, this is a combination lagging process. If you look at the lagging process, this is a combination lagging process. That means the duration of activity is 2 days, but lagging is all about starting and finishing. So if you take the example of E, this is a very good example of why lagging is so important. Even though E is a duration of only 2 days, E is a short task. Activity E has got duration of 2 days. But if you look at the lagging process, lag of 2 and lag of 2 from start to start, from finish to finish. So that means we are restricting E that is truly dependent on D. So the start and completion of E is dictated by start and completion of D. So 18 is once D finished, all right, within 2 days, E must be finished. Which leg is more preferred? What do you mean? Daniel? There is no solid answer to that. It depends on the project network diagram. So there are multiple types of lags. Depending on the suitability, you can use any type of lag from start to start, start to finish, from finish to start. So there is no such thing as which one is better than the other. It depends on the project planning and preparation process. In some cases, we may need to restrict the completion time. In some cases, we may need to restrict the starting time. Depending on the suitability, we choose ourselves which lag we will be using. That's right. That's right. Okay. All right. So if you move on to the next slide, the next one. This is another one which is a hammock activity. So a hammock is, as you can see from the name itself, a hammock activity is it will not affect the total chain, but it will act as a type of hammock. So say, for example, the consulting work, right, or the auditing process. So these are the hammock activity. It should not add to the total chain, or it should not make the project make it a longer duration, but it can be embedded within the existing chain, and we cannot neglect it. So this is part of the project, and we have to embed it in an existing chain. So say, for example, if you look at here, what is a hammock activity? Inspection service, consulting service. We can also put something like auditing. All right. It goes like any activity that is related to the compliance check. Or you can see in the hammock activity, this is an additional chain that we embed into an existing. So is there no lagging restriction? Then block E can be finished in 14 days. and D. If there is no lagging restriction, yes. So you can we can finish whatever the finish time is. Yes, that's right. So in the hammock activity, if you look at the hammock activity, you can see this is a totally additional task, not within the project chain. What are the hammock activities? That is not an integral part of the project planning and preparation or the actual task, but this is more of the compliance check, a consulting service, an inspection service. An inspector will come and check the work. So these can be treated as hammock activities. Say for example, we have activity B and activity F. All right. So if you look at here, between a B and F, we have a duration of 1, 4, 3. We have a duration of total 8 days. Within, from B to E, we have a duration of total 8 days. So the hammock activity, it must be completed within that 8 days. We are not asking for any extra time. So the hammock activity is from B, D, and E. These are the activities that must be inspected, or a consultant must be present when we carry out these activities, or an auditing process should be carried out when BDF is being done, or a compliance check, a compliance engineer must be on site when BD and F is being done. All right, so these are the additional tasks. We call it hammock activity. It shows as a hammock within the project, within the chain. It shows as a hammock, and the total number of days, it depends on the duration of the activities that the hammock activity is involved in. Remember, this is not additional time, but this is within the time frame. This must be done. The hammocking process that includes inspection, inspection, consulting, auditing, compliance check, whatever it is, it must be done within that time frame. Within those set of activities, there is the additional service must be done. So that's a hammocking process. Any questions, please? No questions? All right. Okay. Then the next one is there are some class activities. So draw the project network diagram from the following information. Which activity is burst? Which activity is a March activity? So I guess since we are not in a physical class, so you must practice it at home. Make sure that you get it right. It's a very simple, systematic approach of forming the project network activity. We have the answer given here, so we can see that it's very simple. So you check the ID number and what is the predecessor activity. So for A, there is none. So A is the first, very first activity. Then D should be preceded by A, C by B. It goes like that. Then you start forming the project network diagram. And another class activity in a very simple word. I have the answer given here. So please check and make sure that you understand the background process and how it works. So practice all the class activities yourself, and the solution is being given here, so it should be easy for you. Then so this one, specifically this one, if you look at here now, we have the duration is given, okay? Using using the duration. Now we can have early start, early finish time, and we can calculate the total project duration. Activity 6, project information, including all the duration is given. So now your task is, if you have a question like this, all the project information, activity ID, then predecessor activity, the duration is given. Can you calculate the project duration? Can you identify critical path? Okay, so make sure that you understand the concept of how to form the project network diagram using the duration, then whether we can calculate the total, and if you can, once you form the network diagram, then from the duration you should be able to calculate the early start, early finish time, then the late start, late finish time, the total slack and free slack. Okay, next one. Again, the solution is given here. Please check all the class activities. Now, I'm happy to explain any of these activities if you need me to, or if you have any questions. You can obviously unmute yourself and you can ask. You can talk. Okay. So read the questions. A large Southeast city is requesting federal funding for a park and ride project. One of the requirements of the in the request application is a network plan for the design phase of the project. Sophie Kim, the chief engineer, wants you to develop a project network plan to meet this requirement. So she has gathered the activity time estimate and their dependencies as shown. Show your project network with the activity early, late, slack time, and make the critical path. So this is a very this is a very typical example of how you can expect in the exam question. So you'll be given a table like this with the duration, right, and how the activities are related. All right. So this is a very typical example of what you can expect in the exam questions. Now, from the duration, you should have a clear understanding of how much time A should take to complete, right? And how B, C, E, all these activities are related, and what is the total duration. Okay. So once you have this table, it's very easy to form the network diagram. So you start from A, right? Now B is preceded by A, C is also preceded by A, D is also preceded by A. So A is kind of the burst activity that is bursting into B, C, and D. Okay, so that's how you, from one step, you start forming the project network diagram, which is here. So A is bursting into 3 activities, A, B, and C. All right. The first step is you must complete the network diagram. Then you can start filling the early start, early finish, and the total duration. So then E and F, E is preceded by B, C, D. All 3 is, so E is the merging activity, as we know. All 3 is merging into E. This is a merging activity, right? Then we have F, G, H, everything coming from E. So E is again bursting into FGHI, which is here. So FGHI bursting into 4 other activities. Then all of those are again merging into FGHI is again merging into J, right? So now we have J. This is the first step. As soon as you see a question like this, the first step is check the activity, predecessor activity, form the network diagram, right? Once this is done, then the next step is look at the duration. Duration is on the very last column. You can see the duration 5. You can see the duration number. Then start from A, which is 5 days. So if you check the now that you have the project network diagram completed, all right, then you start filling the early start, early finish time. So early start for A, if you start from day 0, right, we know the duration, which is 5 days. Okay, if you put 5 days here, we know the early finish of, so what is the critical path of activity A? So let me, what is the critical path of activity A? We can get to that point once we finish the total duration. So then we have the early finish time, which is 5. Now I'm explaining this from the very basic level because my understanding is some of you may it may not be clear how you get to that final number 155. This is important, and also to identify which one is the critical chain on the activity network diagram. Okay, so we need to understand how we got this one, how we get to that 155, and which one is the critical chain. So once A is done, then the next one is the duration of B, C, D, 20, 30, and 5 days. So now that we know early finish time for A is 5 days, so that 5 should be the early start, early start, early start. We have the duration given of all 3 activities. We add up the early start, and then we have the early finish, and then early finish. That should follow out of all these 3. We have 10, 20, and 35. We cannot start E until we have this C is done. So C is a critical activity. So that follows to the next step, which is E. The duration of E is given 80 days. That add up to 115. 115 is, that should be the early start of all FGHI. Then we have the duration given for all, which helps us to identify the early finish time. Okay, then from here the lowest the highest is what, 145. So 145 is a critical chain. Okay, so A, C, G, J. That's right. So A, C, E, G, J. So this is the critical chain, and the total duration is total duration of the project 155 days. Right. So using the backward pass process, in a similar approach, you can see from the backward pass process, you can, another way of identifying critical chain is look at the slack. Slack will be 0, 0, 0, 0, 0 within the critical chain. Always that will be 0 days. Using the backward pass process, once we finish the backward pass, we have the idea of the total slack. So the question is what it says. So show the project network with activity early start, late slack time, and mark the critical path. So this is a very typical question that you can expect in the exam. why it is written that the completion time is 150 days? Oh, that is a typo. Yeah, yes. LS and LF2, okay. All right. So now we have, this is LS, LF. So LF for late finish and LS for late start. So late finish is, we can take the time from here, which is 155 days. We must finish the project in it is 155. We must finish the project in 155 days, right? We know the duration. We subtract 155. We have 145 is the late start. Okay. Then we in the backward pass process, we start from the back and then we come to the we start from the right side. We then subtract the duration. We calculate the LS. So from 145, this is what? This is the late finish for all the preceding activities here. We subtract 15, we get 130. We subtract 30, we get 115. We subtract 25, 125. We subtract 15, 130. Subtract the duration from the late finish. This is the late start. And what is slack? Slack is the difference of early start and late start. So if you subtract this, you can see the slack 0, 0. You can see the slack here. 35, 35. Slack is 0. 5, 5. Slack is 0. 5, 30. Slack is 25. 115, 120. Slack is 5 days. So if you subtract, you get the slack in any chain. That's slack. Okay, any questions? That's all for today. I'm here till another 15-20 minutes if you have any questions. The slack in I should be 15. Yes, it should be 15. Thank you all. How was it? How was it? How was the first online session? That's great. Yeah, I'm missing classroom AC too. You all are missing classroom. This is we. I mean, this is the best of our ability. We cannot just stop the semester, and that will be a significant delay in the completion of your degree. A lot of you will be delayed, may be delayed by 6 months. So we can't afford that, and most of you won't be able to afford that. Delaying by 6 months. A number of you are waiting for finishing your master degree. This is your last semester, so you must finish on time. And with the current situation, this is the best. This is the best we can do at this stage, right? We cannot just stop everything and then wait for 6 months for everything for situation to come back to normal. Yes, we'll be having online classes for the rest of the semester, unfortunately, yes. Assessment task, I can give you the detail of assessment task. Give me a minute. So midterm test, midterm group project will be 30%, case study 20%, final exam 50%. I will let you know the midterm project. Midterm project should be, let's go one by one. So midterm project, you should start forming a team of 4 people in each team. I will release the midterm project. For the case study, you should have at least 3 to 4 case studies. Case studies will be released soon. Yes. So midterm project and case studies, this is pretty clear. So I will be releasing some case studies. You have to answer, you have to read the case study, and you have to answer specific questions based on those case studies. That is 20%. Let me put it this way: if we have 4 case studies, 5% each, you answer. This is individual submission. You submit the answer by the submission link from iLearn, and that will be 4 case studies. So 5 times 4, 20%. Okay. So we have roughly about 8 weeks remaining from now. So let's do it this way. So every 2 weeks, there will be a case study of 5% until week 13. Okay. So one is coming by end of this week. All right. Every 2 weeks, we'll have a case study, 5% each. Then remaining 30%, which is the midterm project, I will be releasing midterm project question by end of week 6 or latest week 7. But in the meantime, you need to understand all the fundamentals. So I must finish at least to lecture 6 or 7 by the time you can start working on the midterm project. All right. So midterm project is a big project of 30%, team of 4 students in each team. You should form the team already by now. You cannot meet in person. This is a federal offense. More than two people meeting in the same place, it's a federal offense. So you cannot plan to meet physically in anyone's place. So you have to work online, discuss on the phone, using Zoom or Skype or video chat, whatever. Can we make a group of 5? Okay, a group of 4 to 5 maximum 5. Okay. How to make the group? So select select your team who you can best work with, and I will be providing a link through iLearn. You should submit the group proposal. Okay. Can you assign groups? So can you assign? Okay. So those who want to form their own groups, they can do it, and they can submit to me that this is our group. Those who don't have a group, I will assign it myself. You can use the same group, yes. So those who have a group in the contract of in the procurement course, yes, you can work on the same group. That's better, yes. All right. Team of 4 to 5. If you have the existing group from the procurement course, that's very good. You can still we can continue working on that team. If you want to form your new team in this course, that's fine. Submit. Make sure that you are forming a team of 4 to 5 maximum, and remaining ones, those if you don't have a team, I will allocate myself randomly. For the case studies, let me think the best approach, because I don't want you to overburden with lots of tasks. All right. Okay. It's all good. My first time experience on the Zoom. I hope it went well, and please be with me if you see any technical difficulties, any other problem with this format of lecture. I wish you all the best, and please look at iLearn for regular communication. In the meantime, if you have any questions, obviously you can drop me an email, or you can drop a post to iLearn discussion forum. All good. Thank you all. Thank you. Attendance will not be tracked. There is no marks for attendance. No. Final exam is there will be detailed communication coming from the Vice Chancellor how we will format, how we'll structure the final exam. This will be it's a university-wide decision. It's not a unit-wide. It's not a decision that I can make. All right, it's a university decision how they want to conduct the final exam. That's not valid anymore. The class class activity, class participation marks is not valid anymore. No, as I said, the assessment task is changed. This is the new assessment assessment component. I'll do it. Thank you all. Have a great day. Thank you all. Thank you. So I'll end the meeting now for all. Thank you.